Welcome to the Daily History Chronicle. Each day, we travel back to discover a pivotal moment that changed the world. These aren't just dates and facts. They're stories of courage, conflict, innovation, and consequence that still echo through our lives today. Are you ready to explore? Let's see what happened on this day in history.
Good morning and welcome to today's episode. I'm Richard Backus, publisher of University Teaching Edition, and every day I get to share a piece of history that I think you'll find as fascinating as I do. On January 7th, 1610, on a cold night in Padua, Italy, Galileo Galilei pointed his homemade telescope at Jupiter. 3 points of light appeared near the planet, 2 to the east, 1 to the west. Stars, he thought, coincidentally aligned. The next night, all 3 had moved to Jupiter's western side. That's not how stars behave. Stars don't follow planets. On January 9th, clouds blocked his view. He had to wait, wondering what he'd seen. January 10th brought clear skies and a shock, only 2 lights visible, both east of Jupiter. Where had the third gone? And there was something new, a 4th point of light he'd never seen before. Night after night through mid-January, Galileo watched these lights dance around Jupiter, sometimes 3 visible, sometimes 4, sometimes only 2. They appeared, disappeared, and changed positions. They were never in the same arrangement twice. By January 15th, the pattern was undeniable. These weren't stars. They were moons, 4 of them, each with its own orbit, circling Jupiter as Jupiter moved through the heavens. He was watching in real time celestial bodies revolving around something other than Earth. This discovery shattered the main argument against Copernicus. If Jupiter could carry moons while moving through space, then Earth could carry its moon while orbiting the sun. The evidence was irrefutable. Anyone with a telescope could see it. But acknowledging what it meant would require overturning 15 centuries of certainty. Picture Galileo at 45, a mathematics professor at Padua. He'd heard about a Dutch spyglass and, within months, built a better telescope than anything in Europe, 20 times magnification, then 30. He'd seen mountains on the moon, craters that shouldn't exist if celestial bodies were perfect spheres. He'd looked at the Milky Way and discovered it wasn't a cloudy band, but thousands of individual stars invisible to the naked eye. But Jupiter's moons were different. They were proof that changed everything. For 1,500 years, educated Europeans believed Earth sat motionless at the center of the universe. This wasn't just astronomy. It was theology, philosophy, and common sense wrapped together. Ptolemy had created an elaborate mathematical model in 150 AD that explained planetary motion with Earth at the center. The model worked. It predicted positions accurately enough for navigation and calendars. It had worked for 14 centuries. The Bible seemed to confirm it. When Joshua needed more daylight to finish a battle, he commanded the sun to stand still, not the earth. If Earth moved, wouldn't Scripture say so? Aristotle's physics required it. Heavy objects fell toward Earth's center because that's where they belonged. If you dropped a stone from a tower, it landed at the tower's base. If Earth were spinning, wouldn't the stone land somewhere else? Wouldn't birds flying west get left behind? Common sense said we'd feel the motion, and there was the cosmic hierarchy. Earth at the center meant humanity was central to God's creation. The drama of salvation, the fall, the incarnation, the redemption, happened here, at the center of everything. If Earth were just another planet, what happened to our special place in God's plan? In 1543, Copernicus proposed that the sun was at the center, with Earth just another planet orbiting it. Mathematically elegant, yes, but absurd. Most astronomers treated it as a useful fiction for calculations, not a literal truth. Galileo's 4 moons made it real. Within weeks, he published Sidereus Nucleus, the starry messenger. 4 moons orbiting Jupiter are visible to anyone with a telescope. He named them the Medicean stars, after Florence's powerful Medici family. The book made him famous across Europe. It also made him dangerous, because if observations contradicted Scripture's apparent meaning and Aristotle's physics, who decided the truth? The Church had spent centuries integrating faith and reason. Galileo's telescope threatened to tear them apart. Not because Galileo wanted conflict, but because anyone could look through a telescope and see what he saw. Here's where Galileo's brilliance collided with his arrogance. He mocked opponents, putting their arguments in the mouth of Simplicio, the simpleton, in his dialogues. He alienated potential allies. He pushed when diplomacy might have worked. The Church initially seemed open to discussion. Galileo made discussion impossible. The Church warned him in 1616. Discuss heliocentrism as a hypothesis, not a fact. Cardinal Bellarmine, the Church's chief theologian, was clear but not hostile. Galileo could teach mathematics, just not claim it as physical reality. For years, Galileo complied, or seemed to. But in 1632, he published Dialogue Concerning the Two Chief World Systems, ostensibly neutral, presenting both Earth-centered and Sun-centered models. But everyone could see which side won the argument. Simplicio, the defender of the old astronomy, was a fool. Some thought Simplicio represented Pope Urban VIII himself, once Galileo's friend, now feeling personally mocked. The Pope was furious. Galileo had violated the 1616 warning. He'd made the Church look ridiculous. He'd embarrassed the Pope. In 1633, at 70 years old, sick and nearly blind, Galileo was summoned to Rome to face the Inquisition. The winter journey nearly killed him. He arrived in February and was held for interrogation for months. The charges: defending the opinion that Earth moves and the sun stands still. Worse, an unsigned document in the Inquisition's files claimed Galileo had been personally ordered never to discuss heliocentrism at all, not even as a hypothesis. Galileo had a signed letter from Bellarmine saying something different, but the unsigned document gave the Inquisition what they needed. They wanted more than silence. They wanted public recantation. They wanted a demonstration that church authority trumped individual observation of nature. At 70, sick with hernias and arthritis, nearly blind from decades of observing, Galileo was shown the instruments of torture: the rack, the strappado, which dislocated the shoulders. He was told what would happen if he didn't confess. For a man his age, the threat was enough. On June 21st, after 3 interrogations, he agreed to confess to whatever they wanted. The next day, June 22nd, 1633, dressed in a white, penitent shirt, Galileo knelt before 10 cardinals in the great hall of Santa Maria sopra Minerva. He placed his hand on the Bible and swore that everything he'd observed, everything he knew to be true, was false. I, Galileo Galilei, have been judged vehemently suspect of heresy, namely of having held and believed that the sun is the center of the world and immovable, and that the earth is not the center and moves. I abjure, curse, and detest the said errors and heresies. The sentence: life in prison. All books are banned. No publishing, no teaching, no discussing his work. Visitors required permission. Legend says that as he left he muttered, "Eper si muove." And yet it moves. He probably didn't. The legend appeared a century later, but it persists because it captures the truth. Reality doesn't change when we deny it. Galileo spent his final 9 years under house arrest at his villa near Florence. Guards watched him. Spies reported on his conversations. The church wanted absolute silence, but they couldn't silence what he'd already set in motion. Copies of his books circulated throughout Europe despite the ban. Protestant countries, delighted to embarrass Catholic authorities, published his works openly. In Holland, England, and Germany, astronomers built telescopes and looked at Jupiter. Everyone saw the same 4 moons. The observations were reproducible. You couldn't unsee what Galileo had shown. Even more remarkably, during house arrest, Galileo kept working. Nearly blind, forbidden to publish on astronomy, he returned to his earlier work on motion and mechanics. He dictated to his students. The result? Discourses and mathematical demonstrations relating to 2 new sciences, laying the groundwork for Newton's laws of motion. Even silenced, he couldn't stop pursuing the truth. The book was smuggled to Leiden, Holland, and published in 1638. Galileo was 74 and nearly blind when his most excellent work appeared in print. He died 4 years later, January 8, 1642, still under house arrest, still condemned, never vindicated. But here's what happened next. That same year, 1642, a boy was born in England who would build on everything Galileo discovered, Isaac Newton. Within 50 years, Newton's Principia Mathematica provided mathematical proof of everything Galileo had observed. The heliocentric model wasn't just correct, it was inevitable. By 1700, even the church's own astronomers quietly accepted it. No announcement, no reversal, they just stopped arguing. Galileo's book stayed on the index of forbidden books until 1835. But truth had already won. The church finally admitted error in 1992. Pope John Paul II acknowledged Galileo was right 359 years after the trial. Jupiter's moons are now called the Galilean satellites, Io, Europa, Ganymede, and Callisto. Spacecraft have visited them, mapped their surfaces. Europa might harbor life beneath its ice. The moons kept orbiting whether the church accepted it or not. So, what happened on January 7, 1610? Galileo saw 4 moons orbiting Jupiter, and the implications were unavoidable. If Jupiter could carry moons while moving, Earth could too. The evidence against Copernicus had collapsed, but Galileo's observations were correct, and his conclusions sound, while the Church's concerns about social order weren't irrational. If Scripture could be wrong about the cosmos, what else? If individual observation trumped church authority, what held civilization together? Galileo was also arrogant and politically reckless. A more diplomatic scientist might have survived. Yet truth won anyway, not through tribunals, but through evidence that wouldn't disappear. Within 2 generations, even church astronomers accepted heliocentrism. Why does this matter today? Because we're still having the same arguments. When climate scientists present data about rising temperatures and melting ice sheets, we ask, who decides truth? Scientists with evidence or politicians with economic stakes? When they show graphs of carbon dioxide levels and temperature correlations going back hundreds of thousands of years, some people question their motives rather than examine their data. When medical researchers present vaccine efficacy data, controlled trials, peer-reviewed studies, millions of data points, we debate credentials rather than outcomes. When evolutionary biologists present fossil records and DNA evidence showing common ancestry, some argue observation must yield to doctrine. The pattern is identical. Observable evidence contradicts established belief. Authorities feel threatened. Instead of examining data, they question motives, attack credentials, and demand absolute certainty before accepting what evidence shows. Meanwhile, the universe operates according to the same laws, whether we acknowledge them or not. Galileo's story teaches an uncomfortable lesson. Being right doesn't protect you. Truth doesn't automatically win. Power can suppress observable facts for generations. Galileo spent his final years imprisoned for reporting what anyone could see through a telescope. But his story also teaches this. Suppressing truth requires constant effort, while truth just has to exist. The church spent centuries enforcing geocentrism. Galileo spent a week looking through a telescope. Guess which one? You can silence the messenger, but you can't silence reality. Jupiter's moons kept orbiting through every trial, every recantation, every decree. When Galileo saw those points of light on January 7th, 1610, he couldn't have known the price he'd pay. But he also couldn't have known those 4 moons would still be orbiting Jupiter 4 centuries later, long after the tribunal that condemned him had become a cautionary tale. The question isn't whether science and religion must conflict. The question is, when you observe something true that contradicts authority, what do you do? When evidence challenges your beliefs, how do you respond? When someone presents inconvenient truths, do you examine the evidence or attack the messenger? Observable truth eventually wins, no matter how many tribunals condemn it. The question is, how much suffering we inflict on the truth-tellers before we accept what we could have learned by just looking through the telescope. Tomorrow, we'll explore another moment that shaped our world. Thank you for your time. If you enjoyed this episode, please subscribe. If you really enjoyed it, please tell a friend. I hope you will join me again tomorrow for more of our shared history.